In this video we'll show you how we can import the Dxf file for the Aerofoil wing section and create a Wire EDM program for that. So I've started the CAD system, so I'll import my Dxf drawing. And that's in inches. Okay, so that's the Dxf drawing that's come through. Now one thing that you will need to do is just to check to see the sort of spans and elements that go to make up this shape. So to do that, if you go to View, Show Near Points, that shows you the end points of all the different spans. So if we just zoom in on that area there, you can see that they're made up of quite a huge number of straight line segments. Now that's not a problem, it's just that you need to be aware of it. Okay, so you can just switch that off at any time. So what we need to do is create contours of each one of those. Now obviously what needs to happen is that the two shapes need to be aligned so that they're in the correct position. Having the Dxf drawing as it is actually makes that job much easier, and I'll explain why. So if we were to just draw an angled line at 90 degrees, and we'll make that okay, so if we go into near snap and I just zoom in on this end part here, so I'll just snap onto it so that it's the actual last point there, and we'll do the same thing here. So now we know where the two extremes of that are. So what we can do is we can create the contours and align them using the datum function. So if we go into create an NC contour, it shows us where the Dxf drawing datum is. Now we want to set the datum separately, so we need to zoom in on this area here, and again let's switch on the near points. So we need to make sure that we're choosing one of the correct element right on the end there. So now we create the contour. Okay, now we can set up whether the smaller of the two sections is the top or the bottom when we come into the EDM system, so we don't need to worry about that right now. This is just creating the contours. Okay, so that's created the one contour. So I set the datum point there and then created the contour. Now when I come to do this shape here, I'll create a contour, but I'll reset the datum to that extremity there, and then create another contour. Okay, so we've now got those two contours. So if we save that drawing away as a PartMaster drawing, I'll call that AM. Right, so having got the contours created, now we can take that through into the Wire EDM system. Obviously you'd need to do exactly the same thing on the inside, but I'll show you how it works on the outside first. So that's all saved away, so now we can go into the Wire EDM module. Right, so you can see what's happened there is that the two contours have been merged so that the datum point for each one is coincident. So if I've got that slightly wrong and you need to move those datum points, then obviously you'll know where the datum points need to be. Right, what happens when you come into the EDM software is that it automatically creates a machining instruction for each one of those contours, but we don't want that, so we can just switch those off, or we can delete them. That happens as a default. If we don't want it to do that, if we go to View Preferences and then we uncheck this box here, Auto Create a Wire Path for Imported Contours, and then it won't do that. So what we want to do is to create a 4-axis contour shape. So we'll choose that. So this is where we choose which one of these contours is at the top in the UV plane and which one is on the base in the XY plane, and the distance between the two. And then if we're cutting around the outside of that, we'd probably want to offset to the right and cut in the forward direction. Now obviously it's important that both of those contours are created in the CAD system in the same direction. Under the Options tab, we specify how far away the pilot hole is, so I'll say 1/2 inch. Click OK, and what that does is it then creates a wire path based on those two contours. If we go into the ISO mode and run it, you can see those lines represent the end points of each one of those spans. If we go back into Plan View and Animate and run, you can see this point here is the pilot hole, which is a distance away, and we have various strategies for how you're going to approach that. Now if those are the wrong way round in terms of the position of them, so the smaller one is at the top and the larger one is at the bottom, then it's simply a question of going into the go round command and changing those two around. Okay, so having got to that stage, we can look at that and choose what it is we want to do with it, change anything we want, and so on. So that will output a full 4-axis toolpath for that. What we'll do next is we'll post-process, but before we do that we'll just run the machine simulation. Now the simulation, you're going to see pretty much what you've seen there, although it will look obviously on a solid. So we go to 3D simulation. We're using a 4-axis EDM machine. Okay, so that's the 4-axis machine, and that creates the data to pass through to the machine simulator, calls up the simulator, and then we just simply press the simulate button. So the material there is based on the stock sizes. We've got simple video controls here, so we can just run that as we like. This controls the speed of operation, so we can see basically what's happening there. If we wanted to, we could have the material shown, or we can show it as transparent. Okay, so that's done that. Exit from the simulator and then post-process. And then the one that we'll choose is, we have various Mac 3 post-processors set up. Now the way that Mac works is obviously it's very configurable, so there may be changes needed to make sure that the output is as it's required. Okay, so here's the outputs there. Now as you can see here, in this particular version of the Mac Post, the axes are set up as X, Y and A and B, but they can be set to be whatever you need them to be, or however the machine is set up. So that's how you do that.